Hi everyone, and welcome to What on Earth? Ever wondered why a car horn sounds high-pitched coming towards you and low-pitched going away? Today we're going to be talking about why.
It all happens because sound is a wave. Sound is produced when something vibrates, like a loudspeaker cone. When the surface suddenly moves out, it knocks the air molecules around it, pushing them closer together, and that bit of air has a higher pressure. There is then a knock-on effect, where these molecules push on the ones next to them, and they push on the ones next to them, and so on, so that this high-pressure zone travels through the room. We call this a wavefront. It hits your eardrum, and that's what you perceive as sound. This happens many times a second, and how often you get a wavefront hitting your eardrum, or the frequency, determines how high or low-pitched the sound is. The faster the loudspeaker cone is vibrating, the higher the frequency, and the higher the notes you hear. All the wavefronts travel through the air at the same speed. The speed of sound in air is 330 meters a second. So, the frequency the speaker gives off is the same as the frequency you hear. Okay, so that's all fine when both you and the loudspeaker are standing still. But what if the speaker starts moving away? The speaker emits one wavefront when it's here. It's moving away from you, so by the time it emits the second wavefront, it's slightly further away. The second wavefront has to travel further, so it takes more time to get to you. The same thing happens with the third wavefront, and so on and so on. The waves are stretched out, and there's more time between them. Fewer hit your eardrum every second, and so the sound gets deeper. The reverse is also true. If the loudspeaker is moving towards you, the wavefronts are bunched up, and the frequency increases.
So that's what's called the Doppler Effect, and it's why a car horn changes in pitch as it moves by you. You can also hear it in the whoosh of a passing car, even if there is no horn. That whoosh is white noise, a hodgepodge mix of different frequencies, caused by a whole lot of different things, like the deformation of the car's tyres on the road. Because it's such a mix, you can't hear any one distinct note, but you can still perceive the entire thing moving up or down, because every frequency in there is Doppler shifted by the same amount. This doesn't just happen with sound. All types of waves undergo this phenomenon, including light, which after all is just another kind of wave. Light also travels at a set speed. The speed of light in a vacuum is 300 million meters a second, and the frequency determines its colour. High frequencies are found at the blue and violet end of the spectrum, while lower frequencies are found at the red. This is why if light is Doppler shifted to a lower frequency, it's called a redshift. XKCD has a really nice comic about this, and I'll put the link in the description below. Using this knowledge, we can determine whether a distant star is moving towards us or away from us. The scientists can work out what mix of colours a star should be emitting. If we point our telescopes towards a star and find that the frequencies are all lower than they should be, by the same amount, it means the light has been redshifted, and the star is moving away from us. In fact, this is exactly what we find. The experiment was first done by an astronomer named Edwin Hubble. When he looked at distant stars and galaxies, he found that they were all redshifted. All of them. All the stars are moving away from us. And that is how he established that the universe was expanding. From little things like car horns to big things like the expansion of the universe, we can find the Doppler effect in some pretty interesting places. Thanks for watching, and remember to spread the science.